Hello friends, welcome back to my YouTube channel Unlock Your Learning. In this video we are going to solve congruency of triangles exercise 20b. Alright, and this is the third question. So what have we got here in the question, right? It says here that just have a look at it. See, if MP is equal to NQ, right? Prove that triangles OMP and ONQ are congruent, and hence prove that MN and PQ bisect each other at O. So there's a lot of thing in this question, but we'll understand it with the help of the figure. Fine. Now here you can see that we are given with two triangles. Fine. One is what you can see it's given. One is this one, right? One is this. You can take it anyway, OMP and ONQ, right? From here you can see the pointer, right? So OMP. Okay, this one is one triangle, and then the second triangle is this ONQ, right? So there are the two triangles given to us, and one more thing is given to us is that MP is equal to YN or NY, right? Now this means these two sides are equal. Alright, second is that angle Q and angle P are right angle, that is 90 degrees, right? So they are 90-degree angle. You can see it's given in the question itself. There is this little square that is made over this P, right? You can see this one where the red color pointer is hovering, and then here as well on point Q there is another square, right? So uh, these are the two things that are given to us. I'll highlight this as well so that it's a bit clearly visible, right? So this one is right angle triangle as well. Sorry, right angle triangle. Now you see that we have to prove the congruency of these two triangles, that is OMP and ONQ, right? So what have we got here to prove? First of all, you can just keep on writing it down with me, that first we have to prove it, that to prove what have we got, triangle OMP is congruent to uh, right, is congruent to triangle ONQ, right? And second thing that we have to prove is what is the second thing that we have? MN and PQ bisect each other, right? MN sorry, this is MN bisects PQ, right? You can write it in the other way as well. Totally, it will be fine. Now you see that these are the two things that have to be proven in this question. Next, what has it said here? What all information is given to us basically, that is MP equals to YN, and this is given to us, given in the question, right? Given. Second is OPM is equal to OMN, right? So triangle OPM is equal to angle OMN, right? Not triangle, angle, right? And this is equal to 90 degrees. Fine. So this is equal to 90 degrees, and same reason given, it has been given in the question only. So these are the two things that are given. Second thing, you need to find it out on your own. See, what is that thing over here? You can see we all have learned about this concept of vertically opposite angles, that is, if two lines intersect each other, the opposite angles are equal. Okay, this one is equal and this one is equal as well, right? So this is what it is. See, two lines are intersecting each other, so this will be equal to this, right? These two angles will be equal because they are intersecting and they are the opposite angles at point O. MN and PY are intersecting, and you can see these two angles, that is MOP and YON, are opposite angles. Fine. So they will be equal by vertically opposite angles, right? So angle MOP is equal to angle N this NOQ, right? And again the reason will be vertically opposite angles, right? This is what the reason will be given. Now you see that we have got here one thing, that is we have got two triangles, okay, two triangles and one pair of sides which are equal. Now you see one more thing, that the side that is equal is not between the triangle, but it is between the angles, but it is uh, opposite to the angles, right? It is not between the two angles that are there, it is not between them, but it is instead opposite to them. Fine. So this means what? That two angles are there already and then one side will be there. Fine. So angle, angle and side, AAS, right? This is the method by which our triangle will be congruent. Fine. So therefore triangle OMP is congruent to triangle ONQ, right? So the reason will be what? Angle, angle, side, right? Let me just check the sequence, because the sequence has to be correct as well, right? Then only we will get our correct answer. So OMP and ONQ, fine. So the sequence is correct. Now we have to prove. See, one thing has already been proved. This is the first thing that has been proved. What is the first thing? That was to prove the congruency of the two triangles. You can see it here. Second thing that we have got to prove is that MN is bisecting PQ. Now come to the figure once again here. Now you remove everything that we had, basically you can just let it be, it's totally up to you. You see, we have to tell that this MN, right, see the red color cursor here, this MN is bisecting this PQ. Fine, this is what we have to tell. So MN is being bisected by PQ. Now we know these triangles are congruent, and we have studied about CPCTC, that is congruent parts of congruent triangles are congruent, or you can also say it as CPCTE, that is congruent parts of congruent triangles are equal. So using this thing, using this CPCTC method, we can say that the corresponding sides will be equal, right, or corresponding parts. So we can say PO, right, this is PO sorry, so this is PO and this is QO, right? These two sides will be equal. This is MN and this is MO and this is NO. Again, these two sides will be equal. This is because of what? Because of this what do we have it here, that is congruent parts of congruent triangles are equal, CPCTC, right? So this is what it basically is, that is OM is equal to OM is equal to ON and PO is equal to OQ. I'll show you here. We have studied that method when we use the sides for finding it out. See, OM, so M and O and the first letters of the other triangle, N and O, these will be equal, right? So OM, oh yeah, I'll write it with a black color only. So OM is equal to ON CPCTC, and another thing will be what, that is PO is equal to QO, right? This is P and O, right? P2O. So first and the last letter of the first triangle, so O and Q, that is first and the last letter of the other triangle, right? So OP equals to this is NQ, fine. So NQ, and again same thing, congruent parts of congruent triangles are congruent. With this we can say that hence that PQ bisects what? What was that? MN, right? So, or you can say MN bisects PQ. Now, how do we say this? See this over here in the figure itself, that bisect means dividing into two equal parts, right? Now, if you closely look at it, you can see one thing here, that MN is from point M to N, from here to here, this is MN, and this MN is being divided into two equal parts, from here then one or till here, right? So this is what it is, that it is being bisected into two equal parts. So this is what it is, and this is how we prove that our triangle is being bisected. First of all, we prove the congruency of the triangle, and then we prove that these two lines are bisected using this CPCTC rule. Fine. And friends, this is all for today. If you are new to my YouTube channel, do not forget to subscribe and leave a like on this one. Till then, take good care of yourselves and bye bye.